Okay, this next video is going to be about elastic collisions. So let's just go ahead and start off with an example. This is where the two objects are going to bounce instead of stick. They're a little bit harder. You need to know a little bit more information, but we'll get into that after the example. So we'll just keep things really simple. We'll have one box, and it's going to be moving. It's going to collide into another box. And let's go ahead and put some numbers on here. Let's say that this one has a mass of 5 kilograms. Its initial speed is 8 meters per second. And let's say this has a mass of 2 kilograms and its speed is 0. Then some time is going to pass and then they're going to collide and they're going to bounce. What makes it tricky about elastic collisions is now there's more information we need to know after the collision. So in this particular problem, here's the given information. I'm going to give you information, then we'll solve for a missing piece right here. I'm going to say that this 5 kilogram block has a speed of 2 meters per second after the collision. And then what we're looking to figure out is what's the speed of this one. And this was a 2 kilogram box, right? So we're looking for the speed of that second block. Now the same idea goes here. What we need to do is use conservation of momentum. So we need to add up all the momentum before the collision. That's going to equal all the momentum after the collision. So we're just going to keep that together and we're going to solve for what's missing. So before the collision, here's what I have. I have 5 kilograms times 8 meters per second plus 2 kilograms times 0 meters per second, which of course will give us 0. That's going to equal 5 kilograms times 2 meters per second plus 2 kilograms, and I'll call this VF right there. Might be better if I called it V2F, but that's fine. We'll keep it like that. So let's see, now we just do a little bit of math. I'm going to drop my units just to keep things a little bit neater here. Extend that down. I'm going to say this is 40 plus 0 equals 10 plus 2 VF. I get 30 equals 2 VF. So VF equals 15 meters per second. Now it's always good to go back up a little bit and see if that actually makes any sort of sense. All right? Let's see if that makes any sort of sense. So I had this box, 5 kilograms at 8 meters per second, colliding into something that was 0. And afterwards, this heavier box was going quite slow, and then this one turned out to be 15 meters per second. It seems pretty reasonable. If I have something that's really big that bounces into something that's a little bit smaller, it makes sense that this smaller thing might get going really fast after it got bounced into. So that makes some sense right there. So let's see. The thing that makes it tricky about elastic collisions is that there's more information than you actually need to know. So you have to actually know what's the velocity of one of the boxes afterwards. Let's do another example just to see how that's going to work. Let me draw a big line here. All right. So another example of how this is going to work. Well, let's say now I'm going to have two objects that are going towards each other. So I have this guy. Once again, we'll just keep with boxes. They can be cars or football players or whatever else you want to do to make it interesting. Let's say that this is, once again, 5 kilograms, and I'll have it going at 4 meters per second. Now I'm going to have a box going toward it, just for fun, to change things up a little bit. And let's say that's 10 kilograms this time, and 2 meters per second. The tricky thing about when you have elastic collisions is I still need more information. I still need to have more information in order to get what is going to be the end result of this.